Welcome everyone. Time of flight mass spectroscopy can be used to find the relative abundances of the different isotopes present in a sample of atoms. This data can then be used to calculate relative atomic mass. Kinetic energy calculations often appear on A-level chemistry exams associated with this technique. These are often some of the most challenging numerical questions you could be asked. In this walkthrough, I'll show you how to approach a TOF question and how to show your working out. This should help you get method marks even if you don't arrive at the correct final answer. This is the format for the walkthrough. It's from an A-level chemistry past paper. Details are in the description. Let's get started. Here's the first part of the question. All ions are accelerated in an electric field and have the same energy. The heaviest ion will have the longest time of flight. The answer is given in blue. You must give the mass number 138 and include the positive charge. Next, we have to calculate the length of the flight tube. There are 5 marks available for this part of the question. It is essential to show your working out in full. First, we can calculate the mass of a single barium-137 ion in kilograms. Electrons have very little mass, so a barium-137 atom has virtually the same mass as a barium-137 ion. 1 mole of barium-137 plus ions will have a mass of 137 grams. To find the mass of a single barium-137 ion, divide by Avogadro's number. This is given in the question. To convert from grams to kilograms, divide by 1000. The mass of a single barium-137 ion works out to be 2.2750 times 10 to the minus 25 kilograms. I have recorded a mass of 5 significant figures to avoid rounding errors in the final answer. Next, we can use the equation Ke is equal to a half mv squared. It is always a good idea to rearrange the equation before substituting numbers in. This could gain method marks. Multiply both sides of the equation by 2. Then divide both sides by m. To make v the subject, take the square root of both sides. Now we have the equation in the correct format, substitute the numbers from the question to find v. Take care with inputting lots of numbers into a calculation like this, especially when you are using standard form. Practice with your own calculator so that you're familiar with the various buttons and functions. The velocity of the barium-137 ion works out to be 5.6646 times 10 to the 4 meters per second. Again, I've kept this result to 5 significant figures and included the units. If you've worked this out and you get a different result, make sure that you haven't forgotten the square root function. Velocity is equal to distance divided by time. We can rearrange this to make d the subject. The time the ion takes to travel the distance of the flight tube is given in the question. Substitute the data into the equation to find d. The answer works out to be 1.54 meters. All of the data used to calculate the final answer is given to at least 3 significant figures. It is appropriate to use 3 significant figures for the final answer. It is a good idea to use at least 5 significant figures in your working out to avoid a rounding error. That was quite a long calculation. I hope you found the explanation useful. Once again, it's really important to show your working out clearly to get method marks if you slip up before the final answer. Thanks for watching. Please like, subscribe and hit the bell for notifications. Post in the comments if you have any questions or suggestions. Take care and good luck with your studies.